to our webinar around lessons and barriers in moving to a circular economy in the process sector. So we have our talk, which we're going to go through, and this event is organised by the Sustainability and Environmental Working Group of the Process Industries Division of the IMechE, whose vision is treasuring our planet for future generation, which is a really interesting thought as we look in across all our different process sectors and really compare and contrast and think about the lessons and barriers in moving to a circular economy. Today, we're lucky enough to have some fabulous speakers with us who I will introduce shortly, and we're going to focus on the parts of process industries, which is upstream and downstream oil and gas. So let's just move through so I can mention a few little housekeeping notes. The event will be recorded, so please be aware of that. And you are able to get a CPD certificate, which we will give you some contact details for that at the end. We are going to have our talks from Alan, Steve and Cecil, and then we'll have an opportunity for you to submit some questions. You can do this through the chat box or through the Q&A, and Pamela and I will be sort of checking those boxes really closely to try and get through as many questions that we possibly can. So as we move through, I just want to mention a couple of things. You might not have heard about the Process Industries Division, but we really do focus across all areas of process industries. And as you can see there, from different focus areas, from bulk materials right the way through to food and drink and wastewater, water and wastewater. And we really want to get you involved. So please come along to our webinars and our organised lectures and seminars that we have. And I'll talk a bit about a few of them that are up and coming just before we finish at the end. And obviously, as we move through, we also want to make sure that it's very important to us within the Process Industries Division that we really put diversity and inclusion at the front of our thinking as well. So we just want to kind of share that with you. But let's move on a couple of slides and I will do my introductions so you can be aware of who's talking today. We are incredibly lucky to have some fabulous speakers, and I must as well call out at the start a big thank you to Pamela, who's in the background making sure all the technical aspects of this webinar work. So Pamela Robinson, Senior Mechanical Engineer with United Utilities. And coming back to our speakers, we've got Alan Barton, who's not only a member of the Process Industries Board, but he's a real long-term expert in sustainability and resources. And we also as well have Steve joining us, talking about upstream oil and gas chemicals from the Technical Oil and Gas Chemicals Technical Committee. He actually chairs that committee in that part of the Process Industries Division. And then also as well, we have Cecil joining us, who's got a brilliant talk connecting to what's going on at BP at the moment. And he chairs the IMechE Oil and Gas Technical Activity Committee. So again, part of our IMechE Process Industries Division Board. And then you've got me. I work for Johnson Matthey. I chair the Pharmaceutical Committee, and I'm a member of the board too. So here we are for our talk today. Now, I think, Alan, it's really important to ground us in this topic of the circular economy as we start. So could you please set the scene?
Okay, well, I'll set the scene and explain why we need a circular economy. But first, I'm going to talk about how did we get to today. Well, there were three major events that occurred between those dates. We discovered affordable sources of energy, we had an industrial revolution, and our population started to increase significantly. In fact, it went off like a rocket, as has our ingenuity, our GDP, our ability to produce power, and our use of the planet's resources. So why do we need to take action? Well, our population is destined to increase, potentially up to 12 billion. And we're living outside what the planet can sustain. We've got to stay within the circle, within the green. And we've gone outside with regard to greenhouse gases, the diversity of our animals, our use of land, our use of water from rivers, and more importantly, our use of green water. And green water is the water that grows our crops. Use far too much fertilizers, and we've produced an enormous amount of toxic materials. And our carbon dioxide in the atmosphere has increased, and that's caused our temperature to rise. And now roughly 50% of our planet is there to feed us. And in the past 6 years, we've used over 500 billion tonnes of materials, and that's nearly as much as the entirety of the 20th century. And in 2023, we produced 2.1 billion tonnes of municipal waste. And there is a view we are at the start of the 6th mass extinction event on this planet caused by us. And most of the time, we've lived in a linear world where we've taken materials, made them into something, and then simply disposed of them. And we aspire to move to a circular economy. But if this report is right, we're actually going backwards. And this is an interesting graph. It plots human development index of countries and the number of planets it takes to provide that way of life. And my question is, for 8 billion people to live the same as the average of the top 20 developed nations, how many planets do we need? Well, the answer is 3.6. Guess what? We've only got one. So what must we do? Well, we must deliver on the UN sustainability goals, and we must start treasuring our planet and have circular ecologies and a way of managing our home in a circular way, a circular economy. Particularly with regard to greenhouse gases, the natural world, material resources, water, atmosphere, and population growth. So as greenhouse gases, we must get our carbon back in balance again and deliver on our COP promises, focus on all greenhouse gases and all sectors that produce them. And we really do need to develop a joined up plan to get us to the point we wish to be. And then if we can get back to pre-industrial levels, that would be great. The natural world, well, we've got to stop reducing it and re-establish the natural world and deliver on our COP promises. Material resources, well, we must treasure our material resources. We've got to realise that the planet's inorganic resources are finite and never disperse them beyond the reach of future generations. We've got to reduce consumption and consider whole system thinking when we design things and produce no waste. As far as water goes, well, we must treasure and manage our water. And we can use nature to help us solve some of our problems. But we've got to stop polluting our rivers and oceans. And if we can get the global ocean temperature to decrease, that would be brilliant. Atmosphere, we've got to stop polluting our air and strive for clean air, including clean technologies for transport. Population, well, hopefully if we provide a reasonable lifestyle for all and better education globally, our birth rate will equal approximately to our death rate. So we need circular ecologies and a circular economy. Now I've got some difficult questions for you. Will we be able to sustain our current way of life? Can we sustain our current economic model? How can we live using one planet's resources? Is humankind doomed? Yes, things aren't too bad, but they're getting worse, and we potentially have some tidal waves coming at us. So we need to start acting seriously now. Is it inevitable? Is there hope? There were 3 moments when humankind achieved incredible things. In the Second World War, the United States increased its production of ships and planes significantly, and we won a war. We put a man on the moon, and we produced a vaccine very quickly. We need that mindset applied to living in harmony with our planet, because provided we do, and we get on with it now, I think there is hope. And then if we all play our part, hopefully we can make our planet smile. Thank you.
Thank you, Alan. You've really done a great job there of positioning our circular economy. Yeah, definitely treasuring our material resources, stop polluting our water and our air, and just making sure we have that joined up plan. So maybe moving now on to Steve, because based on some of the things Alan was presenting as ideas, what would you like to share with us about upstream oil and gas?
Well, some about the upstream oil and gas. Some of it is basically about energy efficiency. There's a lot of detail in this slide, so we're recording this so people will be able to go back and have a look at it later on. So one thing we need to understand is that with the current production of energy that's required, we are still expected to produce 50% of our energy from hydrocarbons in 2050. But you notice that in the projections there, we're also increasing. We're always needing more and more energy. We need to wonder ourselves, why do we need that? Some of the stuff that Alan discussed there. Let's see if it's, no, I get down the slide, there we go. So I thought I'd start with something non-controversial. Drill, baby, drill, the oil industry. So since Mr. Trump told us that we should be drill, baby, drill, we looked at that. If the oil industry starts producing more oil, it's a global market, so the price drops. If the price drops, then the drilling slows down, people are laid off, and the oil price drops again. So we end up with an oil price being set globally, not just by one politician. And it's interesting that since making the statement, the oil price and drilling have barely changed. But the US needs more energy, and it's mostly for AI expansion. AI and Bitcoins is using more and more energy. And people can ask, well, is that helping the planet a lot, or is it just helping some rich people? But the amount of energy that's used in Bitcoin and AI is unbelievable. Use an enormous amount of energy, an enormous amount of resources. But one of the other things that was hidden was that in addition to drill, baby, drill, Trump also said, mine, baby, mine. And the US administration have put an almost enormous amount of taxpayers' money into the coal industry. They're opening federal lands, slashing royalties, and extracting more coal. And the reason for that is that the US has got large coal resources. But it's impossible for that to produce that because it's not a reliable power grid. The peak demand that's required is absolutely enormous, and coal's simply not going to do it. Now, this is one of the main reasons that if you look at the oil and gas there, large construction projects, whether you drill, baby, drill, it's going to take 5 to 7 years to get that major construction project out there. On the other hand, look at offshore wind, onshore wind and solar, 1 to 2 years, a much faster turnaround time to get your energy onto your system. So look at the rest of the world. I've stolen this from the Telegraph, and it's a very interesting graph. The blue is China. Solar and wind power projects under construction. Brazil, the UK, very small amount, Saudi Arabia, the US, the light blue section. So China is going for solar and wind power projects, mainly because it can be turned around extremely fast. And China wants to expand its AI production, that's why. They also want to get away from high-cost hydrocarbon imports. They're allowing market forces to determine electricity generation sources. So what have we learned? Expansion of the future market is dominated by AI power requirements and air conditioning and keeping those units cool. Renewables are a much faster way to increase energy production, and we can see that's a much better way for the planet as well. Electricity from oil and gas, coal and nuclear are high cost to build and always deliver late and leave legacy issues. So the message here is that political interference is a major blocker to an energy efficiency. I'm talking about energy efficiency. I'll be using those two words all the way through here. So let's look at it in the UK market. The price of electricity in the UK is set every half hour by the marginal cost of the last generating unit to be turned off to meet demand. You need to try to understand this. So I've got a small illustration here. You can see that renewable in the yellow is much cheaper to produce and faster. Nuclear's almost as cheap, coal, but gas is expensive. But because gas is the last generating unit to be switched off, the price of electricity in the UK, no matter whether you live next to a wind turbine or a nuclear power plant or an oil and gas, it is set by the last to be switched off, which is always gas. So the gas price sets the UK electricity price. The government had considered a zonal pricing system, and that was basically that you would have lots of electricity in one particular area, so the price would go down using market forces, energy efficiency. Under the scheme, power costs would match local supply and demand. It would lead to lower energy cost, and areas that would be abundant would possibly get some AI farms to go up there and build them up there where it's cheap electricity. And that's used in Australia, Italy, Sweden, and many other countries. And you can see that at the moment we have all the map shows the location of UK data centres, and they're all located down towards the south. But all the cheap electricity is being produced up in the north. And we're having to build massive pylons, highly inefficient energy inefficiency to pump it down south. But the Labour government decided not to produce that because the cost of electricity would have increased in the Labour voting areas in the south. So what have we learned from that? Renewables are a faster way to produce to increase energy production. The UK power grid is a blocker on the UK. We get 60% losses in some cases from producing energy in the north and taking it to the south. We've got to build it, a lot of public opposition, and we're not getting an efficient circular economy. So political interference again can be a major economy. Now this was blockers for getting to the circular economy. So political is a bit of an issue. But there is another way, opportunity. So if we create a micro-circular economy for yourself, don't involve politicians. In other words, this is the idea of putting solar panels on your own roof. Don't connect up to the national grid. Don't use energy sources where the price is set globally. Believe market forces that renewables are faster to install. Or do what Texas does. I was amazed when I heard this story from Texas. Texas is now, it was the oil capital of the world. It's now the renewable capital of the US. You can see that it's now beaten California. Texas is the red line. And it's the ease of building and connecting new renewable projects. They have a system where you can have one guy who will produce electricity and he can sell it to another guy locally, and it's called a connect and manage system. So the two systems tied together, you're not pumping electricity all the way across the country and losing half of it in the way of doing that. You're producing it locally and connecting it locally, and you can much more efficient system. And I can't stop without saying geothermal. Geothermal is the great untapped, unrecognized energy source that could be the source. The potential is absolutely astronomical. People need to consider that. And that is my last slide. I'll stop sharing. Oh.
Thank you, Steve. Wow. Interesting about that bit about renewables being the fastest way to kind of increase energy production. And I hadn't appreciated about some of the pricing elements. That's didn't appreciate how much the UK power grid is a blocker. And yeah, some interesting things happening there in Texas. Perhaps we can explore that a bit further in the panel discussion. Which reminds me, please, by all means, attendees, pop your questions in the Q&A if you have anything that pops up from the presentations as they're coming through, and we'll do our best to answer them. But now if you move on to Cecil, and you're going to talk a bit about some interesting case studies that you've had direct involvement in.
Yeah, we'll do. Are the slides coming through okay and the sound?
Perfect. All
Okay.
good.
Great. Yeah, so we've been learning a little bit in this discussion now about this circular economy, and I wanted to try and connect a couple of projects that I've worked on over the past couple of years in BP that I think tie into this. There are a lot of buzzwords, that we use almost interchangeably at times: sustainability, circular economy, net zero. But there is a point where these things kind of tie together. So I'll move through here. So in our agenda, we will talk a little bit about sustainability and the circular economy, what that means and how we can interplay and interlink these terms and what we do in industry to help our whole global economy and the UK too as part of that. And the UK and Europe are leading the way in a lot of this. You know, we are setting up kind of industry pioneering projects that are really helping us to decarbonize, to reduce our carbon footprint, and to be ultimately more circular and sustainable in the way that we produce and the way that we process materials and energy. We'll touch a little bit as well on the synergies and the broader impact of the circular economy, but really the body of this presentation does focus on the two kind of mini case studies that we'll go through, which is the Net Zero Teesside project, which you may have heard about, and then one you may not be as familiar with over in Germany. That's the Lingen Green Hydrogen project that we're working on too there. So the relationship between the circular economy and net zero goals. I thought this was quite interesting because, again, it looks at how we can pull all of this together in our kind of decarbonisation, net zero, circular, sustainable ambitions for mankind. We all work for companies, and we all need to try and make a profit. We need to produce something that's useful to society. But as we do that, we've got to protect the planet that we live on, and we've got to protect the air and the environment. But through circularity, we can do a lot of this in sync and harmonisation. So the first bullet point there, or the first subheading, emissions reduction through circularity. I think that's a good thing to consider. We do want to reduce our emissions, how much effort and energy it actually takes to extract and produce something from raw materials. If we can reduce that extraction, we can reduce the amount of energy that we need to put into to getting that material. If we can maybe get that material from elsewhere, whether it can be a recycled, something that's reused, something that's coming from another industry, then we're helping to promote that circular economy again. But then at the other end of the scale, once we've got our material, we've processed it, we've produced something useful to mankind and society, that linear route that was described earlier, what do we do about the waste at the other end? What can we do with that waste? Can we reuse that? Can we capture that? Can we extract it somehow, as opposed to just disposing of it and not making any use? Can we really change our patterns of performance over the next few decades? If we can do that, we will be able to continue to lower our carbon footprint. So lower emissions means a lower carbon footprint. We're not digging and drilling and mining for raw materials if we're able to get them from elsewhere, if we're able to use other materials to repurpose and recycle them in other industries. And that again will help to drive sustainability. Okay, so maybe our first case study then, Net Zero Teesside project, pioneering carbon capture and industrialised decarbonisation. Now it's worthwhile spending a second just trying to understand what that really means in that title. So we do want to get to a place where we are able to produce energy or products with a net zero impact on our environment, paying particular attention to methane and carbon emissions with the amount of climate change we're seeing increasing globally now. So that's one aspect, being able to generate energy in a net zero, through net zero processes. The second piece I like too, which is about decarbonising our industries. The world's gone through an industrial revolution in various phases, and this has created massive industrial zones. One of these zones in the UK is in Teesside. We need these industries, and we need people to produce and manufacture things for us. It provides jobs, it provides products, but we need to do it in a way where we are not harming the environment. And these are some of the technologies that we're trying to use to do that. So when I consider the Net Zero Teesside project, it's principally two projects in my mind. One is creating a power station that operates from gas, so it is from hydrocarbons, but then we capture the waste, we capture the CO2, and we make sure that does not go into the environment, it doesn't go into the atmosphere, and doesn't help to contribute towards climate change. This is the UK's first net zero industrial cluster project like this. and it's quite exciting to be part of it, and it's good to know that we are testing these now at scale for the next wave of energy creation in the UK. So the objectives definitely include reducing CO2 emissions, supporting clean growth of industry, and creating green jobs. So we want to continue to have an industry, a process industry, that grows in the UK, but these jobs will need to evolve. It won't be traditional plants that we've been used to be working on. It won't be. My career started in coal power stations, and the world's going to be a very different place in the decades to come, and we want to support that. The second part of the project, in my mind, focuses around decarbonisation and carbon capture, utilisation and storage. So this is where we capture the carbon from the power station, but also from all the other carbon emitters in that industrialised zone. So we use modern technologies, which is a collaboration between several large major global companies. And we work together in this consortium supported by the government to maybe really put our heads together to think about how we can combine our technology and our skill sets and our assets. So once we're able to capture the carbon, CO2, we then need to transport it, and we'll bring it through a plant which is designed to have CO2. We'll process the CO2, we'll compress it, and then we'll send it out offshore into existing geological formations that we've used in the past as a country to extract oil and gas. But we will now inject CO2 into the underground reservoirs, repressurizing them and safely storing the CO2 so it doesn't get to atmosphere, sealing that in the wells that are in the North Sea. And then carbon utilization, looking at ways that we can use carbon back in industry and in society too, and the economic benefits that can come from that. This slide really focuses on the power of collaboration and partnerships. It's often a difficult thing to do when companies traditionally work in competition. That helps the end user. It helps to keep prices low, but it stops people really helping and to deliver technology and to solve big global problems like we have with climate change, for example, or sustainability challenges, or to build a circular economy. We do need joined up thinking. So industries or institutions like the IMechE help to pull minds together from different industries so that we can work on that. But then companies have to do it too. So we are working in partnership with other companies. We're working in partnership with industry and research organisations, and also working in partnership with the government who helps to fund these projects. This leads us to emissions reduction so that we don't generate as much carbon, we don't put that into the environment, and we reach our environmental sustainability goals. But we also have a positive economic and industrial impact, that we're able to create sustainable industries that will be able to continue for many, many decades, creating jobs for many generations to come. So a wonderful thing to be part of, and it's great to see that the UK is progressing that. You know, we have actually broken ground here. We are building these plants now as we speak, and working with other companies to see if we can help to decarbonise them too in the UK. And this isn't the only major net zero project happening in the UK. There is another one too, but we're not directly associated with that, but it's always good to see. Now maybe stretching our minds a little bit further afield as we cross the North Sea and we head into mainland Europe. This is a project on one of our refineries in Lingen. So it's a BP plant. However, it's a traditional refinery, taking oil and gas and processing that. But now we're looking to move away from powering the refinery and the local area with coal to powering it with hydrogen. And to do that, we've modified and updated our refinery, or are in the process of that. Again, this project has broken ground. So the Net Zero Teesside project's about $3 to $4 billion in value. This is a much smaller scale, but has an equally sized impact, 150 million euros. So an overview of the project. Lingen is a small town that you may may not know, in Lower Saxony, Germany. It's quite a good location from an industrial point of view. The refinery's been there for a very long time. Refineries last for many, many decades. Generations of people work on the refineries, but now we've got to a point where we are evolving this refinery into what the 21st century needs, what Earth needs as we move forward, so that we can look at generating sustainable energy. It will produce 100 megawatts of electricity using electrolyzers, and generate 11,000 tons of hydrogen, and that hydrogen will then be used as fuel for the power stations. The project timeline is from 2025 through to 2027, and we'll commission the refinery's adapted green hydrogen location, and it is part of a major European hydrogen economy boost. Got some strange acronyms in here, IPCEI and the Hy2 Infra Commission, who are helping to fund this project. So again, one of the challenges is collaboration, but when we have industrial bodies and governments involved, we can create organisations that help to bring minds together to generate green hydrogen and sustainable circular energy. So through this, we are generating energy from a renewable source. The power from the electrolyzers comes from wind farms via a power purchase agreement. So that way we do ensure a zero carbon energy supply. Why is this important? Well, it is strategically important for Europe and for the local and the major economies. We'll be able to produce green hydrogen, so hydrogen that's generated from renewable energy sources, as described before, as produced to just stripping the hydrogen atoms out of the hydrocarbons, like we've been able to do in the past from methane. We can also expand, so it's got scalability. We'll be able to tap into the wider German hydrogen pipeline or network that they're looking to build at the moment, so that we can continue to expand that around Germany, and similar projects are being considered in the UK too, and other areas in the world. Australia's looking at it quite seriously as well. So we'll have a renewable energy integration program, so where we are linking wind energy to power purchase agreements. We're generating green hydrogen, and we're using that hydrogen instead of burning fossil fuels, and we're not generating CO2 discharge, so we don't even have to capture CO2 if we are burning hydrogen. So quickly for the challenges, I think I'm at the limit of my time. Infrastructure readiness. These commercial agreements and pipelines are not fully in place yet, so we are still looking to build the customer base of who we can sell the hydrogen to, so that we do have reliable distribution. Economic viability. The profit margins are smaller than oil and gas companies are typically used to, so that poses challenges. Hydrogen pricing, we're not sure how that's going to go in the long term. That too generates challenges and financial risk. Hence, having the backing of government, things like that are so essential. And then scaling technology. How can we use all of these electrolyzers and scale offshore wind power, for example, or solar power, to be able to make sure we are generating energy through green sources. But policy and regulation. Again, as governments change, politicians shift, the policies change, the regulations can change, also funding and support can change. So that is a key risk and challenge. So hopefully we will be able to overcome these challenges as we prove these projects over the years to come, and then we do continue to build our circular economy. Thank you. I think that's my final slide.
Thank you very much. Really interesting there to hear about all the collaborations that are going on with even just those two projects that you were talking about, Cecil. Really that importance of partnerships, stakeholders, as we move, as these kind of come to fruition. So I'm going to move now, and maybe if our speakers could put their cameras on, and we'll move through to our panel discussion. Now, I think there's one question that kind of came through in the chat, and I'm going to put that one through first, because I think it's a bit of a clarifying question, Steve. Because one of the things in your presentation, when you were talking about the examples in Texas, There's a comment here from Felix saying, you seem to be describing microgrids in Texas. Is there any law stopping that from happening in the UK?
Well, as far as I've switched off my camera, the signal was getting a bit funny there.
No problem.
There's nothing to stop it apart from the fact that, you know, it's back to the old question of, okay, we have a solar power and we have wind power. What happens on a dark, windless night? So you always end up having to connect to the grid for your backup system. But the alternative to that is that have a system which only needs power alternatively. You know, like we were talking about hydrogen production. That's the sort of thing you can switch on and off as the power is available. You know, that sort of way to do it. And the other thing about, you know, I was going to suggest was the oil and gas in the future. You know, there is a place for oil and gas in a future circular economy. The planet can deal with a certain amount of oil and hydrocarbons being burned, but it's not. We should be using it much more wisely than we are doing it at the moment. The major advantage of hydrocarbons is its energy density. It's very high energy density, so it can be used very efficiently for things like transport where energy density is needed. So I believe that things like aircraft, where you need a high energy density to produce the energy, those should be reserved for hydrocarbons. But other things like producing electricity to produce Bitcoin, that doesn't make any sense at all. You know, we showed that graph there. And in fact, I'm going to show it again. I'm just going to share it again.
I think what's sticking in my mind was something you said, every Bitcoin transaction equivalent of, was it a backyard full of swimming pools? I didn't quite catch it, but sort of, Steve.
Yeah. So can you see that slide again?
Yes, we can.
So you can see the renewables are much cheaper to manufacture, much more cheaper. Renewables so much cheaper. The use of gas was the cheapest form of energy, but not anymore. That's changed. So if we simply allow market forces to take over, then renewables will be the one. Certain things oil and gas are much better at. So we should allow them to be used in the economy, a circular economy, but not use oil and gas to produce Bitcoin. It doesn't make any sense.
So, Steve, you broke up a bit there, but I think you're advocating that our energy solutions or the choices we make are not one single thing, but a bit of a balance, and also being sensible. And I think it comes back to where Alan was talking about at the start about treasuring our material resources. And I think you're advocating the same point around use what you've got as wisely as possible based on hydrocarbons sort of being high energy density. So thank you for that one. Maybe there's a thought here, Cecil, that comment. Do you think oil and gas has a place in a future circular economy? So clearly some of the projects so far are looking at switching perhaps more to hydrogen, was the example from Germany, yes?
Yeah, that's right. So that is about switching and generating energy through green, sustainable methods. I think another thing we didn't have time to mention, but we've explored and progressed a number of sustainable aviation fuel projects. So again, these are often closely linked with government legislation. So if we can generate aviation fuel from sources, anything from waste, oil, that chip fat, industrial oil, and these types of waste, again, it becomes a type of hydrocarbon that can be processed and can be used. And it is a transition. So it may be 5-10% in the years to come of the aviation fuel that's sustainable, but we could continue that trajectory till eventually we are maybe 100% potentially.
Thank you. And interestingly, there's a question popped up in the chat. Oh, Alan, maybe before I move to a different question, I think you've probably got a comment.
I just make the point that, you know, fossil fuel is incredibly valuable material in all the other things it can be done with it. So burning it, to me, is just a bloody waste. But we do have to go through a transition. And, you know, ultimately, if you look at the long term, fossil fuels will finish. So, you know, society needs to come up with solutions, and the sooner we do it, the better.
Oh, very fair point. The question from Christopher was talking a little bit about perhaps I know we've only covered a couple of fuels here, but a comment about what is the outlook for synthetic fuels? You were starting to mention about other sources then, Cecil, but talking about sort of a green hydrogen not being the best fuel for power generation compared to something like methanol or ammonia. But I guess, have you got any thoughts on that? I think the work you've been doing at Lingen has been on hydrogen rather than any of the biofuels, but I don't know if you've got any thoughts or perspective.
Yeah, I don't know too much, to be honest, about synthetic fuels, really, but I think hydrogen has been the fuel that's been opted for by many countries and industries. Again, it does come back to maybe Steve's point, the kind of the calorific value and the energy density of what you're getting from the hydrogen. But in Lingen, you know, we're shutting down 2 coal power stations to generate power from hydrogen, and obviously we're confident that's going to work. Otherwise, our refiner won't produce anything. We won't make any money. Biofuels, biofuel projects are harder to address, but often easier to switch over in the refineries. We've been considering a large number of them, but again, it comes down to some of the challenges. If we can't get the right customer base, and we can't be confident we are going to make a profit due to that, then it becomes difficult to sanction these projects. It's a hard challenge for industry and for the world. It's a fair point.
Thank you. Hey, I know we've got time for a couple more questions, so please keep putting them through in the chat. But I love this one, and it's one asking both of you as speakers to comment. In your presentations, you talked a lot about options to be constructing new engineering, new facilities, new plants, new connections. And there's a question here about, in that construction, what role does the circular economy play in that part? Can you comment further about the circular economy when we're spending, I guess, a lot of time, effort and energy constructing new equipment and sites? I suppose it's challenging the thinking end to end, I guess, on these new innovations.
Maybe
I think
I'll
that's a
mention a
question
little
for
bit.
Alan.
Oh, sorry, I
Is it
didn't
Alan?
say which one first, did I?
Okay.
The one. Steve, do you want to go first, please?
I was just going to suggest that's a good one for Alan. He knows all about that.
Oh, I'm keen to understand what you know, Steve.
So the what was the key question again? The key part of that question was basically, what is the in the circular economy, when you manufacture something, when you use it. Well, I've looked at that. There was some stuff done by the IMechE a couple of years back about electric cars. How much energy is put into manufacturing an electric car, and the batteries, and all of that energy and time and money that's put into it. And then we're producing electricity to pump into the batteries and then put it around. And once that calculation was done, and I believe there was a paper actually published by the IMechE on it, I think it ended up being basically back to the same balance. You'd effectively done the same sort of used the same energy in that whole process of manufacture. The only way to do it is to try to use things for longer. When you get to the point where you're using your cars for longer rather than throwing away, using your clothes rather than throwing them away, that's when it becomes efficient, energy efficiency. It's back to that same thing. So rather than, changing your car or changing your clothes or changing things very fast, which we do in this modern world, we need to start, making it last longer, make do and mend, that sort of thing, and take that whole ethos back to the technology which we have. You know, there's Cecil taking a plant there which is been running from coal, but he's doing and mending and making it from hydrogen. You know, that's the sort of approach that really should work. Alan, I see you've got your hand up.
Yeah, well, that's another question in a different way. If you look at the built environment, tall buildings, etc., 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 there is a lot of work that's been done on the actual materials that are used in its construction. You know, how much carbon do we do? Making the concrete, question mark. How do we design it so we don't use as much carbon in the materials? And there's even, you know, some projects where they're making an inventory of all the materials that have gone in, and they're designing them so that they can take them apart and reuse them. And it's that sort of question, that approach. Is that common in your sectors? Or is it just not considered? Just, you know,
It's not considered at these points in time.
Right.
I've certainly not come across that. Maybe for things like concrete manufacture, that's a big issue. Certainly in the UK oil and gas sector, we're now moving, you know, to generate electricity on the platforms offshore. We were using gas, you know, from the actual wells and using that. But now that's moving across to electricity. They're trying to electrify the power generation out there rather than using the actual oil and gas from the wells. So that's a big push on that sort of thing. But I don't think, and you have to measure it to make sure that that's working. So there is a push for that type of stuff in the oil and gas industry. Cecil's got...
Yeah, I think just on the same point, we're not quite at that stage yet, but I know the discussions that we have or the partnerships we look for are often with some of our suppliers as well. So the steel industry is a big one that we look for. If we can generate green hydrogen, for example, and supply it to their plants and help them produce energy to produce steel, which we're going to still need to use to build with, then we're helping in a circular, sustainable way to generate energy and processes and products. But again, this is, you know, an ambition we're progressing towards, but it's a hard thing to square off. But that could help too.
So there's a little bit of a follow-on question here. So is the focus in the process sector focused on refurbishment, remanufacture of major or minor components? My background is minor components, value of 5 to 100k, remanufacturing wind, and interested if there's a similar focus elsewhere. So I think it's just kind of touching on, I think, Steve, you were mentioning about Cecil referring to reusing an oil and gas plant for hydrogen production. I think what we're coming to is probably it's not as common at the moment, but maybe you think differently. I can see you've come off your mute, Steve.
Yeah, it's not as common, but I know that people are trying to think of some ways to do it. It's very difficult to reconfigure some of the stuff in the oil and gas industry. The big platforms that are out there, they can be reconfigured to be electrical, but a lot of them are getting close to the end of their life, and you start asking the question, is it worthwhile? Because by the time you've got it done, the platform will be finished and all that type of thing. So that does come into it. But you should certainly look at all these questions of energy efficiency, and it's all about in the future, I think, making sure that we use the right form of energy, you know, because hydrogen production, you use a lot of energy in hydrogen production, no matter what. It's only if you've got some spare energy available does that become viable. You know, pure energy comes from various sources. I mentioned geothermal. That's a big untapped energy resource which we really do need to tie into. But trying to use things, that's a good example. The geothermal, they've been using oil wells in certain parts of the world and changing those over to geothermal wells. So that's a good example of using resources which are available and putting it to a more sustainable, and I mean sustainable in a way that, you know, once you've used your oil and gas, you're going to get geothermal for a very, very long time. it's going to be a sustainable energy source. So that's an example of that.
Thank you. We're not far off the end of our session here, so I'm going to start to draw us to a close, and I'm going to share some information then about future webinars before we finish. But let me just kind of come through this. Firstly, I want to say a huge thank you to Alan, to Steve, and Cecil. It's been really thought-provoking to be thinking about how precious our resources are, how important it is that we use them wisely, and that there isn't one single perfect solution. I think in everything you've shared today, it's really a combination of energy solutions, but a critical message in choosing the right form of energy, whether it's something where your suppliers or your customers are close by for what you need, or even if it's just thinking back to that comment about energy density, and even as Alan then was thinking, is burning fossil fuels isn't really our best solution in how we could sort of get this valuable resources used the best. So really to be thinking about energy efficiency in our solutions. Whilst I put the other slides up, any final comments from you, Alan, Steve, and Cecil?
Yeah, I've got one anecdote. I was at a garden centre at the weekend, and I picked up a pamphlet, and the pamphlet was protesting about large pylons going across the local area, and wind farms and a battery, and basically protesting about all of that type of thing. And I turned it over and it said, protest to your government, use our AI tool to to protest.
Sorry. Okay.
Click on the link below and you will be able to use our AI tool to protest about the pylons that are taking the electricity down to the AI centre. I thought, dear.
That's quite a thought to leave us with. That's brilliant. Thank you. Just to let you know, obviously we mentioned we've done other webinars before. If you like to sort of search into other process industry webinars, we record it, as many of them as we possibly can, and you can see a real variety there of different topic areas related to process industries that you can have a look at. So please link to that, and I've left it up for quite a long time, so you have the chance to pick up on the link there through the QR code. I also want to flag that we have 2 more talks coming up very soon on the 23rd of October. It's something to be thinking about, the steps being taken to clean up our rivers. So something about, you know, how our foul sewer system is connected to the surface water system. And I don't know much about that, so it would be good to have the webinar to explain more and see why we've got these combined sewer overflows and what it means for our water courses. And then also as well, a technical talk on the 5th of November, talking about measuring methane in agriculture. So please take a look on the IMechE events pages, and you can sign up for those webinars if you would like. I think now that brings us to the end, so I will just leave with you a lot of the contact details for Process Industries Division, and if you want to know more about being a member of IMechE or connecting to the events pages, I will leave those up for the end. And I guess that nothing left to say, but thank you very much, and we look forward to you joining us again.
Thank you, Claire.